I'm going to show you a couple of filters which initially meet a template, but once their coefficients are quantized, they fall outside that template. Here's the template I'm going for. It's a CCITT PCM template. It figures in papers by Y.C. Lim and others. I've drawn this in with an M file. I'll copy it and bring it over here, transfer it to this. And this CPIG, I'll fold this away as well. Now this CPIG display is just operating in the background. It's slave to Sketch-a-Filt, and the initial filter is already even violating this template. Let's see how it's been designed. I've come in, first off, I've set up a target profile with a cutoff from 3350 to 4600 hertz. I'm operating at the 32 kilosample per second rate that this template requires, and I'm coming in with a frequency sampling filter, and it's doing none too well even in the passband as well. So I'm going to have to try to get a better filter than that. Let me go and get an elliptic, just a classic elliptic. It's going to be an IR filter, and I'll get rid of the frequency sampling one. This immediately shows the irritating fact about these elliptic filters and Butterworths and other classics. The ripples goes down below 0 dB, therefore wasting the space above. I won't worry too much about that. I'll set this to 0.199 because I want to fit it in a corridor which is 0.2 dB on a side, and sure enough it fits in quite nicely in the passband, and I can dive down deeper into the stop band and see what happens, and sure enough it's fitting everywhere, and I can even zoom this dangerous little tang, this little corner right here, and I can see that it's fitting there as well. So I have a pretty good situation. Let me go back to the passband scene to observe what happens. I'm now going to take this elliptic filter, and which is meeting the template, and I'm going to adopt it as a guest. So I'm just going to take it straight away. It's the only filter, so it'll come across, and you can see that it's behind there. Change the color. But now in the user def, I'll make use of the finite word length effects. So I'm going to set this to 10 bits of what? I right click on this menu, and I find its truncation is a sort of quantization, and sure enough this template is being violated quite dramatically. I want this zoom. Well, yeah, I'll get rid of that zoom. I can see this going right outside that passband. I don't like that. And stop band wise, well, let me overlay this again, paste data, and you can see this, well, it's beginning to violate also even in the stop band. So that droop is happening across the passband, and it's quite fatal. All right, let's see this also for an FIR filter. Let me import a filter which is I've already got in the workspace. I'm going to bring it in. It's called H of K, and I'm going to get rid of what I just did, which is all that. Oops, killed everybody in sight. So let me go back and import the guest filter, which is H of K, and in it comes. Okay, this is a 37 coefficient filter, which has been designed previously in one of the other DSP morsels. And let me just convince you that yes, indeed, it's fitting in. So this again is now a initially template fitting situation, and I then go in to quantize that and see what happens again. So again, I'm taking the same situation. I'm going to take 10 bits and see what happens. Well, you notice it goes out a little bit in the passband. As far as the overall situation, you can see it here. The stop band is probably just violating. So I'm violating a passband and stop band as a result of quantization. So neither FIR or IR filters can be expected to be immune to the effect of quantization.